the discontinuity between the upper and lower mantle, what they literally call the transition zone. And again, this is an area between the upper and lower mantle. So basically, it starts at about 254 miles and goes down as deep as 410 miles. But the average thickness of this layer is about 150 miles thick, which would be about the full length from New York to Delaware. And again, this transition zone is in the middle of the mantle. And because of the size of this thing and all the complexity to it, they actually call this thing the second continent, because you got the continental crust on the surface of the earth where the continents and all the earth's land formations sit. And then just below that, you have this transition zone that has all these complexities and formations. And so it's looked at as the second continental crust below the continental crust on the Earth's surface. When they thermally mapped this region, they said that the results were not particularly encouraging, because basically there was just no way that this could be possible, because they found temperatures of 60, 90 to 120 Kelvin just above the middle of the mantle. So we're talking about well below freezing temperatures between negative 300 and negative 200 degrees Fahrenheit. And it was the same readings just below the transition zone, around 60 Kelvin, negative 300 degrees. And then in the middle of the mantle, inside the transition zone, they were getting readings of 60 or even possibly 300 Kelvin. 300 Kelvin, we're talking about 80 degrees Fahrenheit. Temperatures that we would normally expect to find inside of a cave, nowhere near that estimated 2,000 degrees Fahrenheit. But as they continued to map out what was going on down there, they noticed that when the oceanic crust would sink down deeper into the earth, that it would go straight to this transition zone. And that this oceanic crust was actually sitting at the top of the transition zone. It's literally layered across the top of the transition zone like slabs. And these were actually cold slabs that are affecting the temperature of the transition zone. And they're not just sitting on the top, they're also on the bottom and even penetrating through the transition zone, almost like stalactites in a cave. And these slabs are not moving. They're stagnant right at the top and the bottom of the transition zone, almost like they're literally trapped in place, like a barrier around this region. And they say it's literally like this area is shielded from any of the geothermal activity going on in the lower mantle, but that these slabs have helped to spread this area open even more. And there's no type of anomalies like this going on below this 660 kilometer discontinuity. And they've been trying to figure out why these slabs are not moving, but they really don't know why this is happening. Again, like an anomaly in this particular region of the mantle, but there's literally no signs of these things moving. Again, they're acting like a barrier above and below the transition zone, and they're staying at that cold temperature. It's like they're completely unaffected by the thermal activity around them.
This is Geology Bites with Oliver Strimple. The lower reaches of the Earth's mantle extend all the way down to the boundary with a metallic core. That coincided with a rapid increase in computer power, which enabled seismologists to generate images, albeit at very low resolution, of the entire mantle. The images surprised us by revealing some dramatic features in the lower mantle. Alan McNamara is a professor of geological sciences at Michigan State University. He uses computer-based fluid mechanical models to investigate the behavior of the mantle, working in tandem with the seismologists to understand the origin and dynamics of the features we see in the mantle. Alan McNamara, welcome to Geology Bites.
Well, thank you, Oliver. I'm happy to be here.
In my introduction, I mentioned some dramatic features that the seismologists have found in their images of the mantle. What do we see in these seismic tomography maps?
In the regions where we've had subduction, where plates sink back into the mantle, we see that those seismic waves move faster than average in those areas. So that indicates that those areas are colder than average. And usually, if a seismic wave moves faster than average, that usually means the area is colder. And if a seismic wave moves slower than average, that usually means the area is hotter. And that's consistent with what we think is happening. The surface of the plates are cold, they sink into the mantle, and they retain that coolness compared to the rest of the mantle for a very long time. So we see that in the seismic tomography. Between those areas, we have two large regions in the lower mantle, and we call those the large low shear velocity provinces.
Okay, so let's talk about the question of what these things are, particularly whether they're just temperature anomalies or also temperature anomalies with different composition from the surrounding mantle. How do you go about shedding light on this question?
I would say the big question is, what are they? That we don't know. So what we do know is they are seismic anomalies. Additional seismic studies that I haven't talked about here indicate that they probably have very sharp edges to them, meaning that likely that they have a compositionally sharp edge to them. So, but we don't know what they are, what they're made out of, how they got there.
Now, one of the things that they found that could be causing this, I found a couple of years ago when they were able to sample diamonds that came up from this region, from a mine in Botswana. They were able to recover a diamond from this region. And they found that this diamond contained water, and not liquid water, but actually water in the form of ice. And it's a completely different form of ice than we have here on the surface of the earth. They actually call it ice 7. They can form at almost any temperature. Literally, this ice will be at a solid state, even at room temperature. Only thing is, it's only stable at high densities. So outside of a high density environment, it goes back to a liquid form. This ice is only stable and can really only exist at this 660 kilometer region. From what they think, this region is filled with this ice and was likely trapped in these slabs. And again, when they imaged the earth, they got a better idea of exactly where this region sits. And even though the average depth is at 660 kilometers, they were able to get more of an accurate measurement of the exact depth of where this thing sits. And when they measured it, it showed that the depths dropped between 632 to 666 kilometers, which means that this thing is actually dropping down 413 miles or 666 kilometers. And so because of that, many times they will refer to this thing as the 666 kilometer discontinuity when talking about it on a technical level, because technically this is where this region sits. But what makes this more interesting, one of the earliest expeditions out to Antarctica, the 1909 United Kingdom expedition into Antarctica, what was called the Nimrod expedition. And this had been one of the earliest expeditions out to Antarctica, the Nimrod expedition conducted by the United Kingdom. And the name choice is interesting because we know Nimrod is a character from the Bible. And he was supposed to be this highly dominant king that established and ruled over the two most powerful empires in the world. And he becomes so powerful and so influential that he actually ends up inciting a worldwide rebellion against God. The name Nimrod in Hebrew actually means to rebel. Because again, according to the story, he was supposed to have used his influence to encourage this mass rebellion against God. And there's actually not that many references to Nimrod in the Bible. But one of the few is in Genesis chapter 10, verse 8. And the verse actually says, "And Cush begat Nimrod. He began to be a mighty one in the earth." So the verse is saying that Nimrod was mighty in the earth, not on it, not around it, but in it. And it could seem like a whole lot of nothing. In could still mean on. We're all familiar with the story of Job, where Satan comes before the sons of God and speaks to the Lord directly. And the Lord asks Satan where he's come from, and Satan tells him. And what's interesting about this is when the Lord asks Satan where he came from, what his response is, because he says, from going to and fro in the earth and from walking up and down in it. And remember, in the 14th century, about 1472, we get Dante's Inferno. where the main character, Dante, is moving through the 9 circles of hell. And within these 9 concentric circles of hell, you have all the false gods imprisoned down there, chained down in hell. Every single false god, including Nimrod. And they're actually chained deep down in the earth in the 9th ring of hell, chained to the walls of Cocytus, this frozen ice cavern. They're supposed to be imprisoned there specifically for waging war against heaven and sending the earth into chaos in the distant past. And Nimrod and all these false gods are actually imprisoned down there along with Satan, who is specifically imprisoned in ice in the center of hell. Now remember, when they thermally mapped that 660-kilometer discontinuity, the Mantle transition zone, and they started reading those below freezing temperatures in that region. And again, when this area is thermally mapped, these slabs show signs of consistent magnetism, a high level of magnetic resonance that could be potentially keeping them locked in place to the top and the bottom of the Mantle transition zone, like walls surrounding it and blocking it from all the geothermal activity around it. Almost like a description of that frozen ice cavern, Cocytus, where, according to Dante's Inferno, all of these false gods, Satan and Nimrod, would be.